Thank you, Leander. I want to start with a welcome and a thank you for each of the people participating in this training session. We appreciate all of the work that you do introducing AE Techron products to potential users in each of your territories. The purpose of training sessions like this one is to give you tools to help you increase your success rate. So let's get started with AE Techron and complete EMC solutions. To start with some history, AE Techron is first a maker of world-class AC/DC power amplifiers. Products that are low noise, wide bandwidth, rugged, well supported, and a great value. The problem, we were only one part of the solution. We often saw people considering our products only to purchase complete single vendor solutions that were often created from inferior parts and sold at breathtaking prices, and then only to be poorly supported. It was out of this experience we created our first complete aviation test solution, the CIS-25. The CIS-25 system covers all test categories, all frequencies, and all voltages for DO-160 Section 18 conducted susceptibility. And for DO-160 Section 19 induced susceptibility, it covers all tests, all frequencies, and all test cases. A happy side note is that it also covers the low voltage, 14 volt DC and 28 volt DC portion of Section 16 at low currents, and it does mil standard 461 CS 101. So where does the DSR 400 fit in? The power requirements of Section 16 can get large quickly. The CIS-25 is limited to 25 amps continuous and 50 amps surge. If you look at Section 16.7.5.2 inrush current requirements, there is a test that requires the test lab to verify maximum inrush test currents, or inrush currents of the DUT. And these are 9 times steady state at 3 milliseconds, 4 times steady state at 500 milliseconds, and 2 times steady state at 2 seconds. So this puts a huge requirement on the test system to be able to at least deliver these kinds of power levels to make sure that the limitation is not the power supply, but it's the power being drawn by the device under test. To be able to test a DUT to this portion of the standard, the test system must be able to deliver at least 9 times the steady state power requirement. The DSR 400-80 and 160 add considerable power and increase voltages to what is possible with the CIS-25. The DSR 400-160 has enough power to meet the 9 times surge requirements for 14 volt DC and 28 volt DC devices under test up to 30 amps, and for 115 volt AC products with steady state loads of up to 20 amps. If your customer is testing products with higher current levels found in things like electric motors and flaps or fuel pumps, we can create systems able to handle this inrush current for systems with steady state currents of up to 60 amps and deliver surge currents of up to 600 amps. Another important point to make with customers are the requirements found in Section 16.5.1.7. And this is the DC content in an AC signal. It's common to have slight DC offsets in the AC. And so this particular portion of the standard makes sure that the device under test can operate under those conditions. This test requires a plus or minus 0.2 volt DC to be applied to the AC signal. The DSR 400 adds complete coverage of mil standard 704. The DSR 400-80 and 400-160 contain all single-phase AC and DC test levels in mil standard 704G, as well as most test levels from prior standards. This includes single-phase 115 volt, 270 volt DC, 28 volt DC, and frequencies from 360 to 800 hertz. The pair of the CIS-25 and DSR-400 also provide significant coverage of power quality standards for both Airbus ABD 0100.1.8.1 and Boeing D6 36440E Category Z. So there you have it. The CIS-25 and DSR-400 provide complete coverage of DO-160 Section 16, 18, 19, MIL Standard 704, and significant coverage of power quality test standards for Airbus ABD 0100.1.8.1 and Boeing D6 36440E Category Z. I'd like to welcome everybody to this part of the program and introduce Patrick Andre, a longtime friend of AE Techron, someone that if you've sold the CIS-25 prior to now, you will have had some of his services available to your customers. Patrick is someone who sits on the DO-160 Standards Committee and is someone who also includes Boeing as one of his clients. So he does consulting there. We've asked him to talk with us about the DO-160 standard in particular and how it differs, the aviation testing differs from other testing like either industrial or automotive where you typically need to go to a test facility. So welcome, Patrick. And could you talk a little bit about how these requirements, test requirements are different?
Well, sure. Thanks for having me, Larry. The first thing that is important about DO-160 to know is that it is a standard that allows you to self-declare. In other words, you can perform all of your own testing at your own facility. You don't need to go to a certified testing laboratory or have accredited testing performed. This makes the ability to do testing in-house very valuable. There's many companies that I know who they own their own equipment, they qualify their own equipment for aircraft use, and the nice thing about the type of equipment that AE Techron carries is that it is performed, the testing it performs is what we call bench testing. Mm-hmm. This is testing that does not require a chamber or a very expensive anechoic room or anything of that nature, but can be performed on a simple conductive bench. These benches, they have certain dimensions. They're supposed to be 2¼ square meters or larger. Essentially, a 4x8 or a 3x10 sheet of metal can be used as a ground plane for these tests. And as a result, a lot of testing can be performed just in a basic engineering laboratory, developmental type laboratory, and done quickly, easily, and on site without the use of any very fancy equipment beyond the AE Techron system.
What would be the benefit to the customer of having it on site versus going to a facility?
There is a lot of advantages to doing this. Not only is it the expense of a laboratory that tends to go away. That expense is pretty easy to capture. But some of the other aspects are that testing in-house keeps the engineer, the technician, the people of that nature in-house, and so you eliminate travel time, you eliminate time out of house where the person is not available to answer questions or maybe available for other reasons, say meetings or whatever. But there's also issues of when there is a problem during testing. If there's a field failure out at the testing laboratory, that tends to create issues for the engineer or the technician performing the test. Do they have the right parts to fix it? Do they have the right tools? Sometimes they need specialized tools to open up a unit. Do they have the engineering resources that are required? Things like maybe the design engineer being
Hmm.
available to help look at where the problem may have occurred, schematics, parts, and other engineering support. All of those
Hmm.
things are now unavailable at a testing laboratory, but are available at the customer's location, the
Hmm.
manufacturer's location. Well, now you've got an ability to perform the testing very quickly, resolve problems easily because
Hmm.
everything is there. And as a result, a lot of people will end up doing engineering work earlier on in the design and and design in these fixes prior to going to a testing laboratory or prior to doing final testing.
Hmm.
They say that if you can design in an EMI fix, it's 1/100th of the cost of catching it during testing, final testing. And every time you delay one step in the process,
Hmm.
the cost of fixing EMI problems tends to go up by a factor of 100. And this is really true in a case of military and aerospace type testing,
Yeah.
especially aerospace testing, where if you do have to do a recall off an aircraft, now you're
Mm.
looking at potentially millions of dollars of cost in order to fix a problem that you should have caught that's only going to cost a few cents during design.
Who all would be candidates for this kind of equipment? Anyone that's making electronics for an aircraft?
Anyone that has to have any type of testing performed, bench testing or EMI testing performed on their equipment prior to being installed on the aircraft, these are the people that are going to be able to use this type of equipment, your system,
Hmm.
and that type of work will pay for itself quickly because they will have to perform the test at one point or another.
Hmm.
Doing it early, doing it in-house, all of these things are going to save them a lot of money.
When I introduced you, I mentioned that you were on the standards committee.
Right.
And there's been rumor that the DO 160 is due for revision.
Yes.
Is there anything officially or unofficially that you can share with us about the changes that are coming?
Sure. Sure. Um, I am on the SC 135 committee that is updating the DO 160. We are looking for release of DO 160H in December of 2025. I think we're pretty much on track to being able to do that. There are going to be a lot of changes. However, none of the changes will impact how the equipment is going to be used or set up. In fact, there's one test, the chattering relay test from Section 19 of DO 160, that they wanted to eliminate and use another type of equipment. And I was able to convince them, based on the equipment you sell and on some other testing I had done in part of the development of that equipment, to show that this is still a very valuable test and we have left it in. They have now opened up the standard quite a bit to say this is what the waveform should look like, and your equipment meets that waveform perfectly. And as long as that equipment is used, you're going to be able to perform the test. So this upcoming standard is not none of this equipment is going to be out of date as a result of the upcoming standard. And I should also mention that there is a mill standard 461H coming out.
Hmm.
And this equipment is useful for CS 101. And that test will not be changing. So again, in mill standard 461H, this the future of this equipment is still there. It's not going to go out of date.
Is there anything else that you would like to share or you think it would be important for somebody uh, working with this equipment to know?
I have found that the flexibility of this equipment and
Hmm.
the ease of how it can be the tests can be modified and updated to maybe specific requirements a customer maybe have imposed on them. The ability to make these changes is very simple. The equipment's easy to use. The transformers that are have been designed for this system are excellent. I'm very impressed with how well they work, over what range they work, what sort of levels I can get out of them. I've been very, very happy with the performance of this whole system. And like I say, the easy use has been remarkable. And I commend you for the quality of the work you've done.
One of the core components of both the CIS-25 and DSR 400 test systems is the 3110 standards waveform generator. And one of the key advantages of that generator is the approachability using the standards library. So I just want to share my screen with you for a moment and imagine if we were sitting with an engineer and showing them how usable this system really is. You notice up here at the top right, I've got the Files button. I'm clicking on that right now. And we have two options of Standards Library or User Standards. We're going to the Standards Library, and now we have a choice of automotive, aviation, industry standards. Over 3,400 tests from various standards are included in this library. If I click on Aviation, now you see that we have the option of several key aviation standards, including DO 160. I'm selecting, let's say, Section 18, because we're going to run a test there today, and I'm going to select the Ripple Voltage Category B 28 volt test. And there, the test is loaded, and it really is that simple. I was at a show yesterday and was able to just show some engineers how approachable this software is, and they literally gasped and like, whoa, that is amazing, because of the ease of use. And that really is a great feature of this system. You also are able to easily manipulate if you need to add some custom configurations to this waveform, such as, for example, I can drag and drop that simply. If I drag over here though and click on one of these segments, you notice that then down below, I have different wave properties that I'm able to adjust. Because again, sometimes with any aerospace standard, you may need to do some custom modifications for a customer. And so they're able to make that adjustment there. And then in that case, they would save that waveform to their user standards library. The beauty of that user standards library is that then a couple times a year when we update the standards library and send that update to the customer, they're able to upload that update into their 3110 standards waveform generator, and it will not override any of the user standards that they have in that user standards folder. So that is protected even while the standards library is updated for them. So again, this is a very approachable system and very easy to use, and it's one of the great advantages of both the CIS-25 and DSR 400 test systems.
So Patrick, I received a printout, an oscilloscope measure, observation of a piece of equipment that's used for aviation testing. And you had sent me a similar image from our equipment.
Right.
Could you speak a little bit to the quality of the test signal and how important that is for a valid test?
Well, a lot of the methodologies used by some of the power supply manufacturers who perform these waveforms is that they'll chop these things up and into small little bits. And instead of having a nice, smooth transition from one point to another, you end up with these rather ragged lines that you see on the screen here. It's maybe some overshoot, like the very bottom of the, as it reached the bottom of the waveform, it kind of overshot a little bit. And then again, another stair step coming back up. The whole thing is a little bit noisy. Is not a clean way to do it. The beauty of the Techron system, the AE Techron system, is that these waveforms are very precise and very clean. If you see the screen capture I've got from your system here, It's coming in at 28 volts, and it has a very clean ramp down to the minimum voltage. 0 volts goes across, and very clean and precise ramp up. This has been typical of every waveform I have generated out of this system. The 3110 has these beautiful ramps. They're very clean, they're very precise, and they produce wonderful waveforms that are going to be well accepted by any customers, the people who are going to be buying this equipment. They're going to look at these waveforms and they're going to say, this is the type of testing we're looking for.
So even though it's self-declared,
Mhm.
if you are providing equipment to someone like a Boeing or an Airbus,
Yeah.
they'll want to see your test results.
Oh, yeah. You need to report exactly the way you do these tests. You need to show what are the waveforms we are creating. And you need to prove that when this testing was done, it was not only done correctly, but the better quality the work is done, the more likely the customer is going to say, this looks great. Well, we accept your data with no questions asked.